So all of these are examples of non-perfect square roots. So like a perfect square, we can square root it in the calculator, or if you just memorize them, would give you a whole number as a square root. These are all non-perfect square roots. All non-perfect square roots give you a decimal that goes on forever without repeating. So we call those numbers irrational. So if you see on your tests or anything that says we want the irrational solution, it means it does not want the decimal rounded. It wants like an exact solution. So usually like a fraction.
Good morning, Stallion. You're up to Alex with how.
When we say exact solutions, like you might have heard me say before, like, don't give me the decimal unless it's a decimal that ends or something along those lines, like give me the fraction instead. This kind of goes along with it, except for we want you to simplify the radical. Okay, so this square root symbol is also called a radical. Sometimes, for example, it'll look like this and we'll name it 3 radical 2. So like we don't say 3 square root 2, like 3 radical 2 is how we read it. So these non-perfect squares can be simplified. The way that you'll do that, and we'll do the first one together, and then you'll try the next 3, is you want to break it down into its prime factors. So give me 2 numbers that multiply to 24, other than 1 and 24. 2 is prime because it only breaks down to 2 and 1, right? 12 is not. What does 12 break into? 6 and 2. Again, 2 is prime, 6 is not. What does 6 break into? Now, only looking at the prime numbers, I'll even cross out the non-prime numbers so they're not confused. So the numbers that are at the end that can't be broken down anymore. You are going to look for pairs of the same number. So pretend that this radical symbol, the square root symbol, is kind of like a little jail. It even looks like one. In order to escape the jail, you need a partner. So do I have any pairs of the same number? I have a pair of 2s. For each pair, you write it once. And since it had a partner, it gets to be outside the radical. Write it once per pair. The leftover prime numbers, like this 2 and this 3, they don't have a partner. They are set inside the jail. And if you have multiple inside or outside, if you have multiple numbers, you multiply them. So it's 2 times 3. So the equivalent of the square root of 24, the exact answer is 2 radical 6 versus a rounded decimal. When you say exact answer, we want something that looks like that. Question? Can you try the next 3 yourself? Break it down to its prime numbers, look for any pairs, the pair on the outside, and the leftovers stay inside. So table 8, can you tell me what your final answer was for number 2 for the simplified radical? 4 square root 3, you said? Yeah. Okay, let's see if that's right. Break 48 down to its prime factors, and our factor trees can look a bit different from each other, but if you do it right, we should all have the same prime factors. So what are 2 numbers that multiply to 48? And both are not prime, so what does 8 break into? 2 is prime, 4 is not, 4 breaks into. All right, and lastly, 6 breaks into. So break it down to its prime number. So you know it's prime, it just can't be multiplied by anything, get it, other than 1 in itself. So I'm gonna even cross out my non-prime numbers, so the numbers with like branches coming off of them. And just from these, you are looking for pairs of the same number. So I have a pair of 2s here. Another pair of 2s here. For each pair, you write it once, and where do I put it? On the outside of the radical. If you have multiple, you'll end up multiplying them, but I'll do that in the next step. Any leftover prime numbers, like this 3, will go inside. So yes, 4 radical 3 is the correct equivalent of the square root of 40. Good, any questions? Table 9, what is the simplified version of the square root of 72? Or venture a guess? Can you tell me table 9, 2 numbers that multiply to 72? One more time. 6. All right, I'm not good with my multiple results, so if that's incorrect, I'm sure one of you will tell me, right? Because I'm doing like in my head. Okay, yeah, no, that's right. So then 6 breaks into what? Twelve is not primed. What does 12 break into? And then 6 breaks into. All right, and only look at the prime numbers, crossing out the non-prime ones if you need to, so you're not confused. Look for pairs of the same numbers. So table 9, and let me make this look more like 3. Table 9, tell me a pair that you see of the same number. Okay, we have a pair of 3s here. Any others? And then a pair of 2s here. So outside, if they have a partner, they can escape. That tells you to write it on the outside, and you do it once per pair. So any multiples, you'll end up multiplying, but do that in the next step. Class, what should go inside the radical? 2. Any leftover prime numbers? So you have this leftover 2. Simplify, 3 times 2 is 6. So the equivalent of the square root of 72 is 6 radical 6. Simplify. All right, last one, table 1. What's my final answer for number 4? 3 radical 7. So let's see if that's right. Class, 3 numbers that multiply to 63. 7 and 9. 7 is prime, 9 is not. 9 breaks into. And again, don't look at your non-prime numbers. I think they're called composite or really not numbers, but only looking at your prime numbers. Look for pairs of the same number. So for every pair, you write it once on the outside. Any leftover prime numbers do not get to escape, they stay inside. So yes, 3 radical 7. All right, good. Any questions on that, Hayden? Yes. Jack, both, you see Adrian on the board. All right, any questions on the warm-up? Probably one of my favorite things to teach. To me, it's so easy, like it makes so much sense. And just remember that, like, skill analogy. The stuff inside the skill cell, so that the partner gets to escape. One thing you can do though, because calculators can solve a lot of your problems if you know how to use them. Except for like if it's not multiple choice, then I guess it's just hard. But if it's multiple choice and you're trying to figure out what answer is equivalent to yours, so let's take like the square root of 63, for example. It gives me that decimal, and of course Desmos will round because they can't show you all the numbers, right? If I put in my answer options with the simplified form, and I'm just trying to see which one that is, the 3 radical 7, when you type it like that, if it is equivalent, it should give you the same decimal. So that's the way to sidestep it, but still, you should know the skill. You'll use it in your higher level math anyway. All right, so the warm-up helps us to identify our equivalent irrational solutions. That's the goal for today. To find the solutions to quadratics, even if those solutions are irrational. Not, and if you think back to like the projectile motion, not all the x-intercepts are 1. Some of them are the decimals. So this is how we're getting the exact solution. So by the end of the lesson, you need to be able to use the radical, so the square root symbol, and the plus or minus symbols to represent solutions. And you need to know why it's plus or minus when you use square root. I'm recording right now, just like I always do, so make sure we're staying caught up. Puzzle piece is lesson 15. The second half of class, we will have a quiz. It's timed for 25 minutes, so, you know, when we get there to the end of the lesson, we'll do the quiz. I never personally like worry about quizzes that much as far as like how it affects your grades, because when you think about a 20-point quiz versus like a 150-point test, it's really just like a drop in the water. It's just a checkpoint. I have caught people cheating on quizzes and then they're like not allowed to retake them. I mean, it'd be so much worse if you were caught cheating on a test and that's like 150 points you can't retake. Like, it's just really silly to cheat on the quiz. So don't be tempted. You can use your notes. You can come, like today, I have tutoring on Tuesdays until the end of the school year, which is almost there. There's Saturday Academy this Saturday and next Saturday, and then that's it. But like, there's really no point in cheating on the quiz. That's true. Your unit test anyway, and I've always done this, whether you realize it or not. When you score better on your unit test than you did on your quizzes, I bump up those quizzes for that unit. And I have had kids go from like low Fs to high Bs when I do that. Like it's really possible. We only are going to take 3 unit tests this semester, so you can focus like really hard right now. Next week is actually when we're taking the unit 7 test, so it'll be here before you know it. So now for the next activity. I have full confidence that you could do all of these problems because it really is just basic algebra. But the key thing here is that sometimes you'll have irrational solutions, so kind of do what we did in the warm-up and simplify any of those radicals when you see them. And also, anytime you square root, remember the plus or minus. So let's do like the first one together. Anytime you isolate x, you always start with what's farther from the x. So would that be this 2 or this 13? And you always do the opposite in order to undo it. So what's opposite of subtracting 13? And whatever you do on one side of the equal sign. I'm gonna have you do the next 5 yourself. And we're gonna breeze through them because we're not gonna spend a super long time. So whatever you do on one side of the equal sign, you have to do to the other side to keep it equal. What is negative 12 plus 13? If you're more than just Harley. I can hear more of what's going on outside than what's going on in here. So negative 12 plus 13 is good. Opposite of squaring is whatever you go on one side of the equal sign. And how many solutions do I have? 2. Anytime you square root, you should have that plus or minus symbol. What's the square root of 1? So my answer is plus or minus 1. I have 2 solutions for number 1. All right, try the next 5. Always start with what's farther from the x, and to cancel it out, you have to do the opposite. Do that, I'll give you 4 minutes. So when you isolate X, you always start with what's farther, and number 2, what's farther, the 2 or the 6. The 2 is physically farther from the X, so the 2 is farther. What's opposite of squaring? Whatever you do on one side. So that will cancel out this exponent of 2. I have X minus 6 on the left. And whenever you square root 0, that's like the exception to the plus or minus being there. Because what's the square root of 0? And technically 0 is not positive or negative, so that's the one exception to writing the plus or minus symbol. But keep isolating. What's opposite of subtracting 6? Whatever you do on one side. And so number 2 is an example of one solution. Because when you square root 0, there's no plus or minus there. Make sense? Okay. Now number 3, what's farther from the X, the 2 or the 9? Like physically farthest from the 9. And opposite of adding 9 is whatever you do on one side. I get X squared equals 0 minus 9 is negative 9. Keep isolating X, opposite of squaring is. Now what's the square root of a negative 9? Nice try. It's impossible. If you try that in your calculator, square rooting a negative, you will get undefined or another error message. You can use a different calculator, because that is impossible. At least at this level, it's not. So it's impossible to square root a negative. Therefore, when you see that in your problem solving, you have no solution. You can stop at that point. If it tries to make you square root a negative. So no solution for number 3. 2 solutions, 1 solution, no solution. All right, number 4, what's opposite of squaring? Whether you come on one side. And notice that the square root of 18, when you try it in your calculator, is not a perfect square. It's a decimal that goes on forever. We do not want the decimal unless it asks for it. You want the exact answer, so we have to make our factor tree. Do the little like jail analogy of it. Give me 2 numbers that multiply to 18. 9 and 2. 2 is prime, 9 is not. What does 9 break into? Now, only looking at the prime numbers, I'll even cross out like the non-prime numbers. We're gonna put any pairs on the outside, they get to the shape. And any leftover prime numbers go on the inside. So what will go on the outside of my radical? So we have 1 pair of 3, right? 1 per pair. And what goes on the inside? And also, because like I said, there's plus or minus every time you square root. We do want the plus or minus symbol in front of the number on the outside, if there's any. And that's what X equals. So how many solutions is this? 2 still, because it's positive 3 radical 2 and negative 3 radical 2. Anytime it's a plus or minus, it's 2. All right, almost there. Keep going. Starting with what's farther from the X. In number 5, would that be the 2 or the 1 that's farthest? Opposite of adding 1. whatever you go one time. I get x squared equals, 18 minus 1 is 17. Opposite of squaring is everything one side. And 17 is not a perfect square. So you do have to break it down to its prime factors. What are two numbers that multiply to 17? Do you think of any other than 1 and 17? Or is it already prime? If it's already prime, then you can't break it into its prime factors. It's already prime. In that case, you can just leave it as square root of 17 like that. Nothing to put on the outside because nothing can escape. But you do need that plus or minus symbol. Because it's still two solutions. It's a positive square root of 17 and a negative. All right, last one of this set. What's farther from the x, this 1 or this 2? Opposite of squaring is whatever you do to one side. So then I have x plus 1 on the left. This we simplified in this one, so I don't have to go through that again because we already did it. So far I have plus or minus 3 radical 2. But x is still not a 1. So opposite of adding 1 is subtracting, whatever you do on one side. And really, like, you could box this up and write that as your answer. Although most of the time I see them write this number first, the -1, and then the plus or minus. But they're the same, like. There's still two solutions, because you would do -1 and plus 3 radical 2, and -1 minus 3 radical 2. All right, good, easy one. It's all just a bunch of steps. So if you can apply those steps, if you have questions about those steps, then do that. We're gonna look at the next one that's on your paper. It's like at the bottom of the front. And it says, can you solve this trinomial by rewriting it into factor form? So think back to when we solved by factoring. I know it's been like a week. Is this in the correct form that I can start factoring it? What form do you think it has to be in? Okay, so my question was, is it in the right form to solve by factoring? And then I think you guys said that it has to be in this form. Did I hear you right? So this form goes with completing the square. So maybe make like a side note of that. For completing the square, we want it to look like that, like what you guys just said. When we're solving by factoring, or by this other method that you'll learn, quadratic formula, you haven't learned it yet. But when we solve by factoring and that other method I just mentioned, you want it to be in this format and set equal to 0. Okay, so it is in the right form that I can just start trying to factor it using my diamond method. So that's like A times C on top, B on the bottom, thinking of two numbers that multiply to the top and add to the bottom. So in this one, my A times C, 1 times 7 is 7. And my B value is 6. Can you guys think of two numbers that multiply to 7 but add to 6? Right, because there's only 2 ways to multiply to a positive 6 or positive 7, I mean. And that's if it's a 7 times 1 or a -7 times -1. And neither of those add to 6. So this is prime, meaning that it's not factorable, but that doesn't mean that there's no solution. Okay, they can be solved by completing the square and by graphing. And if you flip to the back side, this problem is shown on the back of your paper, and I'll put it on the screen right now, solved both ways. Okay, by graphing and by completing the square. So if you try typing this in during your test, you would see that the x-intercepts are decimals. That's because they are non-perfect squares, like there's a non-perfect square in the problem somewhere. You can see that when this person solved it by completing the square. So you see like they made a perfect square on the left side, they factored it when they went to do the square root on each side. 2 is a non-perfect square. You know, when they kept isolating, they got this. So this would be considered the exact answer. And that will probably be seen on your test somewhere else. But the decimals that it's rounded to are what you'll see on your graph. These are what we call like approximate values. And sometimes it might want the approximation. Sorry, it's like frozen. Sometimes it might want the approximation, sometimes it wants the exact. Regardless, be able to go to both, whether you have to use a calculator to do that, whether you have to just like know how to isolate the variable and complete the square. That's why we teach you all the other methods, because there's pros and cons to each method. Normally, I'd have you try the next 2 problems by completing the square and with your irrational solution. But we're gonna end it there. You'll have time to practice that in future lessons. You do have a quiz. So any questions before you take your quiz? So then the code I will put up on the screen is in Fluidity.